Hello everyone. So here I am taking the oxidation number of chromium in CrO5. So let me calculate the oxidation number of chromium. I'll take CrO5 here. We are calculating for a chromium, so it is taken as X here. There are 5 oxygen atoms are there. I'll take 5 oxygen atom and its oxidation number is -2. So which is equal to 0 here, because the sum of oxidation number of this compound is nothing is there, means it is understood it is neutral and it would be 0. X minus 10, which is equal to 0, which means that X is equal to plus 10. The question is that are we going to have the plus 10 oxidation state for chromium in any of the examples? No. Chromium can never have the oxidation state is which is equal to plus 10. This is never going to be possible, because chromium highest oxidation state for chromium in any of the compound should be, or it should be equal to, it is plus 6. But in this example, we are getting plus 10 oxidation state for chromium. Then which means that there must be something wrong with this compound. No, there is nothing wrong. So what we should do is that we should take the structure of this CrO5 compound, because we should see whether this all the 5 oxygen atoms, all this 5 oxygen atoms are having the oxide linkage or some other linkage here. So let me take the structure for this CrO5 compound. Chromium here, the structure is like this. 4 oxygen atoms are attached like this by a bond called as peroxide bond. Which is a peroxide bond? This O and O linkage is there. This oxygen and oxygen linkage is there. No? This is peroxide linkage. And what type of bond it is? Peroxide bond here. Okay. And this side also you can observe oxygen and oxygen linkage. Again, this is also forming which type of bond? Peroxide bond. And this, whatever the last oxygen is there, doubly bonded oxygen is there, it is having a normal bonding, which is oxide linkage. Okay. So in this case, I'll put a star mark here for the understanding purpose. This all the 4 oxygen atoms, 4 oxygen atoms are involved in peroxide bonding. So all the 4 oxygen atoms, peroxide bonding, all the oxygen atoms should have the oxidation number of -1. Okay, peroxide bonding, oxygen atom oxidation number of oxygen will be what it is? It will be -1. And one oxygen is having normal doubly bonded oxygen. So it is oxide oxygen. And one oxygen is going to have an oxidation state of -2. So according to this one, now we have to calculate the oxidation number of chromium. So let us calculate now. 4 oxygen are involved with the what it is? Peroxide linkage or bonding. So I'll taking 4 into -1 plus one of the oxygen. This one oxygen is involved in what type of linkage here? It is a normal oxide linkage. So I'll take it as 1 into -2. And we are calculating for chromium, so it is taken as X, and again it is sum of all the oxidation number is equal to 0. I'll mention here once again, this is peroxide. Whenever the oxygen is bonded by a peroxide linkage, its oxidation state will be -1. And this one is from doubly bonded oxygen. So I'll write here doubly bonded oxygen. This is going to have oxidation number of -2. And this, what is X here? X is a chromium. So it is -4 -2 plus X, which is equal to 0. So X minus 6 is equal to 0. X is equal to plus 6. So it is understood in this CrO5 structure, the oxidation state of chromium is +6, not +10. Okay, so oxidation state of chromium is +6, it is not +10. And this structure is termed to be called as butterfly structure. It is a butterfly structure. Please do remember that chromium highest oxidation state is +6. It can never have more than